Good
Good
morning.
morning, sir. Yes, sir, it is visible.
Good morning, sir.
That is visible. Okay. So I like to repeat one thing that just like previous day, you will mark your attendance here. Okay. Because you will mark your attendance here. Visible? And that thing is available from here. This is the link. Mark your attendance. Okay. So start marking your attendance. This time it will be 1 because this is we have only 50 minutes. Okay. Somebody else. Okay, and some of you have not written contact numbers. Okay, so I request these people to write your contact number because sometimes it is required when we are everybody in online mode. Okay, sometimes due to some network issue, we require contact numbers. Okay. So you place your contact number if you have not done already, and you mark your attendance as 1 for today because today this is 1 hour class. Okay, now moving on to our lesson. Okay, last time I discussed different types of memories aspect. So now I will write one hierarchy that is very useful in memory system. Okay, the hierarchy actually it looks like a triangle. Okay, now on the top of it there is CPU register. I think it is little bit thicker. And then actually the diagram is not appropriate. Clear that thing. It will look like a triangle. Okay. So first of all, CPU register. Then before getting into the decision control syntax, I have to discuss something about the organization still. Then cache memory. Actually, cache memory stands between CPU and main memory. So if it is CPU, then CPU has CPU register in it, and if it is main memory is considered as a primary memory. So and secondary memory is after that. So you try to understand the concept, and between these two there is cache memory. So CPU can directly access cache memory as well as main memory also. So this is the hierarchy, but it cannot access directly the secondary memory. So as a result, the secondary memory is connected to some to primary memories where you can store bulk of data here, huge volume of data. Those data will be initially fetched to main memory, and main memory is connected to cache. And this is some sort of hierarchy. So now main memory or RAM, better to say, secondary memory, but other than secondary memory, there is another form of memory known as cloud storage. Can you provide one example of cloud storage?
Google Drive.
Google Drive. That is very easy example. There are other examples are also available, but Google Drive is the most common example of, because these things are available in local computers. That means in your computer local PC, but cloud is something available on the internet. Like just like Google Drive, I am writing directly example.
iCloud.
That is also possible.
Adobe Cloud.
That is possible. There are many forms of cloud memories by different manufacturers. But right now I am providing. Okay, let us not. So from cloud storage, there is also possibility to fetch data. It is not directly connected to secondary memory. That means if we require any data, it is directly downloaded into your main memory, and then we can see. Right now you are marking your attendance on Google Sheet, that is available in cloud. Okay, and that is not available in your local machine, but still you can access. Okay, so now what is the feature of, or how have I arranged these memories in this way? That is the key thing, or that is the very important thing, because from top to bottom, that if we move down, actually memory systems are becoming cheaper. That means unit of CPU register is much more expensive than unit of cache, main memory, secondary memory, and cloud. So cloud is very cheap form of memory, where that's why we get a huge amount of cloud space compared to other. And you can also compare in your system that the amount of secondary memory available to us is much more than primary memory. And if you like to purchase them separately, you will also find the difference in price. 1 GB RAM, sorry, 4 GB or 10 GB RAM and 10 GB hard disk. Which one is expensive? If you can compare side by side, you can understand. And that is same. And another aspect is, if we go from bottom to top, these memories are becoming faster for CPU to access. That means if you have more RAM, you can do your operation very quickly rather than somebody who has less amount of uh, main memory. So if your size of cache memory is more, then you can do faster than that. If you have many CPU registers, maybe you don't need to fetch every time memory information from primary memory like that. So when you are moving up, that means from bottom to top, your memory systems are becoming faster. And if you have more of these memories on the top, it will make your system faster, but it will actually add expense to your system. Okay. That means if you buy huge amount of RAM, actually that if it is comparable to your hard disk, that means you like to purchase, say, if not possible, but still if it is 30 GB, 20 GB RAM like that. So, for our PC, so it will be very, very expensive rather than secondary memory. So that is actually the type of hierarchy you have to understand. Hmm. Not hierarchy, it's a type of ordering, and size in our system is comparatively bigger when it comes from top to bottom because we use cloud more than secondary memory. We use secondary memory more than main memory. We use cache more than main memory. So, but unit price is cheaper. Okay, price per unit is cheaper. Okay. Not adding pages. What is the problem? Hmm. Now coming back to one programming issues, last time I discussed how to run a program, how to compile a program. So before getting into programming issues, we must know the program development cycle. So initially we have source code that is in C programming. It is nothing but some .c file, let's say xyz.c file, this type of thing. Okay. So after compilation, it becomes object code. Although we don't get object code because that is consumed intermediate at the intermediate object code. So that is actually .o file, and finally we will get executable code that is usually dot slash a dot out, that is, or sorry, this is the command, not file name, a dot out, or some people can, there is a special command where you can produce your output as the name of your file name xyz. But somehow who converts it from source code to object code? I think the people will call it compiler. But you will later know that source code contains some preprocessor. Okay, so that preprocessor is handled by preprocessor directive, which expand the source code. So there is also preprocessor preprocessor actually converts some part of the source code which has some inclusion statement. Like I had written as include studio.h last time I had written, or there are some other issues like macro. You will not understand that thing right now. When I discuss macro, you will understand. So there are some features are available in C program which cannot be directly translated by the compiler. So this requires preprocessor, but right now preprocessor is not separately available. That is also available inside compiler. So we don't have the view by running the code what preprocessor is or what it is doing. It requires some other types of debugger form of code, but it's not in your syllabus. Uh, so but who convert? How do we convert object code into executable code? Actually, there is a special software, no, system software. Everything is known as linker. You haven't understood. I think you know it little bit what linker is. Last time I discussed, but uh, linker is actually a type of system software that connects your source code with the existing library. Existing library means your program may have many different functions. You only develop main function here, or maybe you develop some functions in the defined function, but your program may have some library function that is not you have developed. Let's say printf, scanf, and there are many other functions possible which you may use, but you haven't developed its definition. What printf is? Why does it print? It must have some code in it, just like we are adding some values. Some so so that kind of code is already available in form of library. Okay. So here you will go. There are many .o files are there. That means many compiled files are there. Okay. So these libraries connected to our original source code. Otherwise, when we use any library function, our program cannot run due to lack of definition of that function. Okay. But there are some other modules are available inside a library which we use directly without defining that thing. Okay. Maybe I haven't discussed, but in your code you will find that there is some other mathematical function. Let's say sqrt is a mathematical function. Actually, it does square root. Similarly, AS is a mathematical function that computes the absolute value. We sometimes call it modulus. In mathematics, it is mod, represented by mod, and it's nothing but a absolute value. So these functions we don't actually define. We can directly use just because their library functions are available in library in form of .o file. So that file is connected to your file, and it is finally the .out file is being prepared. So let us not write the name of the file here because it will be too confusing. So I write only the extensions. It will .c here .o .out output file. In Windows compiler, you will find that .out is not possible. There we get .exe file. Okay, that in form of executable file. So, however, this is the basic scenario. This scenario is not so simple, but I have simplified it just for your understanding that you have to understand what you are preparing. It is not sufficient unless you are connecting to library, because you maybe you are using many different functions, but you are not defining that function. What function what does that function do if you don't specify your program error. So this is one of the aspect you call it program development. Okay. These so far I have discussed, these are nothing but some theoretical aspect. Let us move on to some programming issues. So before getting into direct syntax, we have to get familiar with some operators. Okay. So I think you know already, you know different arithmetic operators. I think we have used some arithmetic operators. Let's say integer a and b, a, b, c. We have used already. This is nothing new. So as a result, A is a 4-byte space, B is also a 4-byte space, and unless we say anything, unless we don't write anything about it, it, it contains some unpredictable value, it also contains some unpredictable value. Similarly, C also contains some unpredictable value because we haven't written any instruction to initialize these values. Initialize means the initial value, setting initial value of the variable. Okay. So this is known as garbage value or unpredictable value. But it's not a blank. Some people consider that when we don't write it, it's a blank. It's not a blank because it's a memory. So, and you know that any digital system, especially computer system, is made of 0 and 1. So memory system is also made of 0 and 1. So unless you override, it will have some default values there. So now, if I set a equal to 100, this is assignment operator. I think you know already. B equal to, let's say, 200. Now C equal to A plus B, if I write, this assignment operator means it actually assigns the value into that variable. Similarly, it also does it. So initially 100 is assigned here, 200 is assigned here, and A plus B, value of A plus value of B. So 100 plus 200. So it is 300 actually, 300 is assigned here. Now in our program, if we print the value of C variable, we will get the sum. This is the fundamental principle I had discussed last time. So here, what operator I am using? This one. This is arithmetic operator plus. Similarly, if you substitute by minus, you will get the subtraction or difference between these two variables. Multiplication, here we write using star symbol. Okay. And there are two types of divisions here. That means if I multiply values, so it will be A star B. Okay. Multiply. And there are two types of divisions here. Okay. So let us consider one simple form of division. Let's say 17 and 6. I am dividing 17 by 6. So quotient is 2 and remainder is 5. So a division has two results actually. This is one of the results and this is another result. So for these two results, we have two different operators. If I write C equal to A by B, that is true division, it is nothing but the quotient. And if I write C modulo division B, A modulo division B, let's say this is A and this is B, then it is, the symbol is like a percentage, okay. Okay, so don't forget about these operators. These are very basic operators. So there are two division operators for division. One is this, another is this. So I don't need to explain because you are very much familiar with these symbols. Even if you are familiar with the star symbol also, but you have to know some mechanisms. Okay, what is new here? I have already discussed assignment operator. So don't get confused with equal to, because equal to actually compares two values, but assignment actually sets a value to another variable. Okay. Now relational operators. Actually it compares value of two variables. The output is true for one or false. Actually, we get value in form of 1 and 0. 1 represents true and 0 represents false. So this is the relational operator. Now, what is the example of it? First of all, I am using two variables A and B. So this is equal to operator. Okay, this is true equal to, and this is assignment. If A and B are equal, then output is 1. Otherwise, if they are not equal, then output is 0. Let's say, if I provide the example in detail, let's say C equal to A equal to B. Okay. If I write, then if two variables are same, let's say A equal to 10, B equal to also 10, then we will get C equal to 1. And if B equal to 20, if you imagine, consider, then C equal to 0. So actually this expression returns true or false depending on the values of these variables. Okay. Similarly, not equal to, we write in this way. Greater than, we write in this way. Greater than equal to, we write in this way because in keyboard we don't have this symbol. Okay. We don't have this symbol, so that's why we write in this way. Less than, we write, and less than equal to, this is something in this way. So is there anything left? Equal to, not equal to, greater than, less than, greater than equal to, less than equal to. Okay. Let us write them in separate lines because it is also confusing. Okay, these are the basic relational operators, output or return of the relational operator. Return is okay, output is true or false. So hopefully you have understood what is the meaning of relational operator. If you have already used Java, so this is nothing new to these people. They have already used. Now logical operators. Actually, there are three logical operators. When I discuss logic gates, it will be clear to you. But still, for the time being, this is known as AND, this is known as OR, and this is known as NOT. So A and B is true if A is true and B is true. Okay. Otherwise, it is false. Now, let me provide one example. Otherwise, this thing is very, very confusing to many people. Let's say A is 10. Okay. Example should be given in different color. A equal to 10, B equal to 20. This is very simple example. Okay, since I have used A and B here, so let us change the name of the variable. X equal to 10, Y equal to 20. Now let us construct one relational expression. Let's say if X greater than 50 and another relation is Y less than 100. Okay. Now if I connect these two expressions using logical operators, and then what is the return? Let's say I am setting the return into variable z or assigning the return into variable z. Now let us analyze one by one. X greater than 50, that is false. Y less than 100, that is true. But rule of AND says that A and B is true if A is true and B is true. But here actually I am find A is false. Here X, this is behaving like A, X greater than 50. Okay. You compare these two with this one. It is false and it is true. So it is ultimately Z will be false or Z will be 0. Okay. Now, if I write, let's say I write 5 here. So what happens under that scenario? X greater than 5, it is true. So it will become true. And Y less than 100, it is true. So as a result, under that scenario, Z equal to 1. So this is the working mechanism principle of AND operator. Okay. So remember that if separately both of the variables are true, then only AND output is true. Otherwise, it is false. Two expressions. And these two expressions are formed using relational operators. Okay. For OR, the rule is A or B is true if either A is true or B is true. False if neither A nor B is true. Okay. So this is the rule for OR. That means either A is true or B is true, and if both of them are false, then only it is false. Otherwise, it is true. So if I substitute this expression by OR, let's say what is the outcome here? Right now the scenario, I am erase it because it will add confusion. Z greater than 5, this is true, and Y less than 10, this is also true. Then it is bound to be true, but if this is 50 again, then what happens? This is false because x is 10, not it is greater than 50. So even if it is false, since B is true, so output will be true. That means Z is 1. If both of them are true or either of them are true, then it is 1. Otherwise, it is 0. So this condition is very easy for us to remember. If none of them is true, then it is false. Otherwise, it is true. If you have used already Java, then I think you have used it, this type of thing. But maybe it is first time for some people. So that's why you have to know a little bit. Okay. And when I discuss logic gates, you will understand this logical operator better, because logic gate is perfectly identical to logical operator. The logic gate is the hardware version of this operator. Okay, where we build gate and implement this logical operations. And not is something, example of not, if I write here, not is A, not A.
ठीक है सर, लोकल
Yes. Yes, any doubt? Not A is true or false, better to say. Oh, okay, true. Not A is true if A is false and not A is false if A is true. This is the rule for not. Okay. So let's say consider this expression x greater than 50 or like that. This is false. So if I write here that not x greater than 50, okay, this is Z considered. So Z is here, this is false, but Z will be 1. Because since this is false, not false is equal to true. Not A equal to true if A is false. This is the rule, okay? And also here, if I consider Y less than 100, this expression, so Y less than 100, it is Y less than 100, this is true. So not A is true, not A is false if A is true. So here A is this expression Y less than 100.
True.
Since it is true, not A is false. Okay. So I think you have understood the logical operator. Any doubt about arithmetic operator, assignment operator, relational operator, and logical operator? If you don't have any doubt, then I will move on to syntax. Okay.
Understood, sir.
Yes.
Understood, sir. Understood logical operator.
Understood. Okay. Now decision control syntax. Last time what I have shown in your program, that program is very flat and straightforward, that there are many instructions we are executing one by one from top to bottom. Let's say there are 10,000 whatever. So it will execute in a sequence. So that is one type of programming, no problem in it. But sometimes the situation is not such simple or straightforward. Okay. So there you have to take care of different types of things. Let's say in our daily life scenario also, if I ask you what will you do tomorrow, like that. So you have to think that if tomorrow is holiday, then I will do something, and if tomorrow is working day, then I will attend the class. Okay. So that is what I will do tomorrow. It's not fixed actually. It depends on scenario. It depends on certain variables. If it is holiday, if it is working day, I will attend classes. If it is holiday, I will go to go out somewhere or watch movie or like that. Okay. So their actually schedule is different. So you cannot perfectly execute a statement without knowing some variables. Okay. So here, under that kind of scenario, we need decision control syntax, where actually the instruction switches depending on the condition of the variable. Instruction changes depending on the condition of variable. Now, here are several examples of this syntax. First of all, if, then if else. Then nested if else. Else if ladder. Ternary operator. Or conditional operator. And switch. So there are many different syntax of if decision for making in our C language. We have to learn these syntaxes one by one. Okay. So let us start with simple if. If without any else. Now let us consider one variable is there, a equal to let's say 10. Now if I write one program, I am not writing the entire program, just a segment where decision making is made, because you have to write everything as include stdio.h main, then include the declaration of the variables like this. Everything is required, but I am not writing this. I am only working with the syntax. A greater than let's say 100, then number is greater than 100. Let's say this is our conclusion. Now before that there are instructions, and after that there are things like that. Now what happens when control executes this part, decision making part? It doesn't check, it has to check what is the value of A and is it greater than equal to. So this time it is not. Then it does not do anything. But if we make it say 110 like that, then it prints the number is greater than 100. So actually that printing depends on the value of the variable, not it is the absolute type of instruction executing. It's not like that this instruction will be executed in all the cases. It depends on your value of the variable. If you put the value or if you assign the value or somehow, sometimes the value is computed, you don't need to assign. Sometimes it's just
लेके जाएगी, क्या खिलाएगी, क्या पहनाएगी, कहाँ रखेगी, उसका कोई ठिकाना है।
टाइम हो गया।
Time हो गया? Okay. Next, okay, I will discuss the remaining part next day. You may leave.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
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 Thank you, sir.